Today's LeetCode challenge is a matrix sum problem. The link of the problem is in the description below, so I highly recommend go and try yourself to solve the problem. So now let's learn what the problem is. We are provided a matrix with 4 rows and 3 columns. Each in the list corresponds to a row, and the values within each in the list represent the element of the matrix. And we ask it to do 2 things to achieve the expected result. First, for each row in the matrix, select the largest number and remove it. In the case of a tie, it doesn't matter which number is chosen. Second, identify the highest number amongst all those removed in step 1, and then add that number to your score. So this is what is asked in the LeetCode problem description. Let's start solving the problem. We need 2 nested loops to iterate over each column I and row j in the matrix. For I in range m, it iterates over each column. For j in range n, iterates over each row in the current column. According to this nested loop iteration, let's do the basic calculation part first. Column 1, I, 0 is max 7663 equals 7. Column 2, I1 is max 2452 equals 5. Column 3, I equals 2 is max 1231 equals 3. So the expected result should be 15 as it's asked in the LeetCode task. So finally, rest is the sum of these maximum values. 7 plus 5, 3 equals 15. Therefore, the output of the matrix sum method for the given input nums is 15. Now let's start. Let's access the elements in the j's row and i's column of the matrix nums and see the results. And what about j's row of the matrix nums? It returns the first list of the matrix. And what about the i's column of the matrix nums? It also returns the first of the matrix. And what about the j's row and the i's column of the matrix nums? Now we see it returns the zeros row and the zeros column, which is 7. Then we update TMP, or the temporary variable, with the maximum value encountered in the current column. In order to update it, we must first initialize a temporary variable rest to store the maximum element in the current column. Initially the rest is 0. Then we can add the maximum value, the current column, to the result. As we see, it returned 6. Then we take the maximum value encountered in the column I. In other words, we update the temporary variable TMP with the maximum value encountered in the current column I, while iterating over the rows j of the matrix. In other words, we update this temporary variable TMP with the maximum value encountered in the current column I, while iterating over row j of the matrix. We see 6 is the maximum compared with the 0, so it returned 6. As we see, comparing the current value of TMP, temporary, was the value of the matrix element in the current position. It returns the larger of the two values, which is 15. So, hey world, we solved the problem. Congratulations.